Let's solve this problem. LeetCode number 69, square root x. Okay, so given a non-negative integer x, compute and return the square root of x. Since the return type is an integer, the decimal digits are truncated, and only the integer part of the array is returned. So you are not allowed to use any built-in exponent function or operator such as the power of x to the power of or like this. Okay, so here is the example. So if the input is x, we are going to return the square root of 4 equals to 2. So this is another problem, the example. So the input x equals to a, the output is 2. So this one, the square root of 8 actually is 2.82842. And since the decimal part is truncated, so 2 is returned. So that means that we only return 2. We only retain this part. And this part we just like truncated. Okay, this is but the problem. Okay, so for this problem, what are we gonna use? So first, so for this problem, we can actually we can think about this. So we can using straightforward method like we can using straightforward like brute force algorithm. Okay, we can use this problem. We can use this algorithm to solve this problem. So the time complexity for this problem is gonna be O(n). So it's like okay, okay. So it's like we can iterate. Let's say 4. Okay, so 1 2 3 4. So we can iterate everything go element here, and then we so like here one so the square root of 4 is 2. Actually in this one we can check if this one is 2, if this one is 2, and then if we found a 2, then we return. So the time complexity for this problem is O(n). But we can also use another one, another algorithm, because we actually want to make it better, right? The time complexity, make it more efficiency. So, so we can use actually binary search. Okay, so what's binary search? Binary search actually is an algorithm that divides the searching space in two after every comparison. Okay, so the binary search should be considered every time we need to search for an index or an element in a collection. Okay, so for binary search, okay, divide the searching space in two after every comparison. Okay, comparison. Okay, so the binary search have three pointer. So we have leftmost pointer, middle pointer, and the right pointer. Also, the binary search mostly have 3 section. We can do pre-processing. Pre-processing is like what? Like we need to sort this array or sort this collection if it's unsorted. So for this problem, it's already sorted, so we don't have to worry about that. So and also after pre-processing, we do binary search. After binary search, we do post-processing. Okay. So post-processing is like we're gonna check the result. Okay, we will talk about this later when we writing our code. So let's do this way. Okay, let's give an example here. X equals to 2. So, no, sorry. X equals to 8. So we are we are compute and return the square root of 8 in this problem, okay? This problem X equals to 8. And then what do we do? Now 1, 2, 3, 4, 5, 6, 7, 8. Okay, for this problem, what do we do? The first element is L, and then this element is R, and then in the middle of this one is M. Okay, so the first iteration, the middle is M. Okay, and then we compute M, the middle, 4 times 4 is 16. 16 greater than 8. So in this case, we're gonna update the rightmost. The rightmost is 8 now. So we update the rightmost to here. And then the middle gonna be M gonna be here. Okay. Okay, now let's do the M by M equals to 4 now. Okay, so the 4 smaller than 8. 4 smaller than 8. In this case, we're going to update the leftmost. So the leftmost will be here. The rightmost still be here. And the middle gonna be here. Okay, so and then this one, the middle times middle gonna be 3 times 3 is gonna be 9. Okay, so the 9 greater than 8, 9 greater than 8. In this case, what do we do? And then we update the right. So here is M, here's the right, and then we stop. And here we stop because we're gonna do a while loop. The search condition gonna be L plus 1 smaller than right. So that means when left and right are neighbors, the search condition will stop. So, and then and then after this, we are going to check. We are going to checking the right. So we are going to do post processing, check the right and the left. So first we check the right. Right times R times R, if is smaller than X or equals than X, then we return right. Okay, otherwise we return left. That's basically the algorithm. Okay, let's writing the code. Yeah, start from here. Left equals to. So okay, so the input of this function is x. It's an integer x. The type of return is int. Is given here. Okay, we return the square root of x. So the return type is also an integer. Okay. And then the decimal digit, we are going to truncate it. Okay, so this is a problem. Now we initiate the left pointer and the right pointer. Right pointer equals to x. Yeah, something like this. And then we do the while loop. The while loop left plus 1 smaller than right. And then what do? We check. So notice here left plus 1 smaller than right. That means when left and the right pointer, when they are neighbors, then the loop is stopped. This is the search condition for this while loop. Okay, first we compute the middle point. The midpoint point here is left plus right minus left, and then by 2. So we do this way because we are trying to avoiding the overflow. Avoiding overflow, okay? And then we compute the square of, we need to put this long because we are doing the square, right? So the data type, so middle point, the square of the middle point. So we convert the middle point, the square of the middle point as a long data type, and give this to the square. Okay, then now we're gonna do, we check if the square is smaller than x. What that mean? If the square is smaller than x, that means the target actually is in the right portion of the binary search. So this way, what we do, this. We update the left boundary, okay? And then otherwise, we update the right. Okay, otherwise we update the right. Okay, after the searching condition is not satisfied, then what we do, we're gonna return. This is long. This is right. This is right. Okay, we check this one. Oh, yeah, we check this one. We check this one with x. Okay, so let's see here why we do this. Let's see here. See here. This is left and right, right? So after the left and right is their neighbors, is the while loop is the stop. So the right, the square of right. So we need to check a square of right if it's smaller than x, like the x, smaller than that, then we return r. We return the right, not left, right? So, or the square of right equals to x, then we return the right. But if x is between the left and the right, like for, let's say, is something here. Okay, so in this way we return x. So that's what we do. We check the right first. If the square of right small or equals to x, then we return the right. Otherwise, we return left. Okay, let's run this code. Okay, line 5. Oh, sorry about that. Here we should do this. Okay, it's accept. Okay, the time complexity for the binary search. The time complexity for the binary search is gonna be O log n. Okay, it's gonna be O log n. So for this problem, let's check the text case. The text case only have one. The debugger. Okay. Yeah, the test case. Let's run. Okay, let's submit the code. Okay, it's good. And the runtime is 2 ms, faster than 77% of Java Online submission of square root x. Okay, thank you for watching. I will see you next time.